Okay, good morning, sixth grade. Or good afternoon. So this is session one. These are questions from session one. We'll go through those. They're the same, the materials that Mrs. Van Houten gave you to take home. So I'll be going through those. It's a really good review for just all the different skills that you're going to want to have for your sixth grade. And we'll go through the questions and then talk about some of the different things. And I just would advise you to take some notes. And just think of it as a review. Even if you know some of these topics, it's still good to take a look at it. So we're looking here at number one, which is which coordinate plane shows a polygon with 4 vertices graphed at, and it gives you these sets of ordered pairs. So first of all, coordinate plane. I think you guys did a really good job in covering that. So this is the coordinate plane right here, obviously. And coordinate planes have graphing points on them. X and Y axis, just really, really important. It's like your GPS system. You have an X and a Y. You have 2 points, and so the GPS is an application of, or it's something that where we use the coordinate plane in our daily lives. A polygon just means a many-sided object with straight sides, and vertices are just corners. So these are just corners, and that kind of pops up every once in a while and kind of confuses people, but that's all we mean. So if you know how to do your graphing, then this question is not going to be too challenging for you. It says you're looking for corners at -5, 5, and of course, if you think back to, you have an X and a Y. So this first one is the X coordinate, -5, and then you have Y is 5. So I could think of it as this way. The next set, 2, 4, I have a 2 for X, 4 for Y. And just continuing, I'll just write them like this just to remind you. Okay. And of course, you do the X first. You go left or right, and then up or down. So we're going to check this one. So we're going to go -5. So we go over -5, and then we go up 5. And so this first one maps out really good. Next one is over 2 and up 4, over 2, up 4. Okay, so we're looking good so far. Over 6 and down 2, over 6, down 2. And here we go. This one is -3, 3. So we're going to go over 3 and then down 3. So this is where this one fails. So it was really close, very close to getting the whole thing, but it doesn't quite come through. Oh, no, I think I got that wrong. It's -3, 6. Ooh, this one may be we may have a winner on the first one here. Hold on. Hold the phones. -3, -6. So we go over 3 and down 6. So there you go. This is our answer here for the first one. So congratulations on that. Let's just go down. We won't spend a whole lot of time on that one. We'll go down to the next one. Let me pause and I'll move it down. Okay, question 2. So here we have, what is the value of the expression? Okay, so first of all, an expression, let's just make sure you're comfortable with that, because we use the term expression and equation a lot. So think about what is the difference between an expression and an equation? This is the expression here they're talking about. So what do you think? So just think about that for a second, and then think in your head, and on the count of 3, say it out loud. Okay, 1, 2, 3. What's the difference? So an equation has an equal sign, and you can kind of see the word equals. It has an equal sign. An expression does not. So we're going to do, what's the value of this expression? Okay, the value. So in other words, we're going to take this expression, which uses exponents. Looks like I can't tell if it has a dot there or not. Whoops. Hold on a second. Oh, let me pause and I'll go. My screen was looking like it was a dot, but basically this is, it's when it's up against that parentheses, it means multiplication. So we have 2. Whoops. Let's see if we can get this. Oh. Okay, back with you. Sorry about that. They're just little glitches, and every once in a while I just stop and just fix things, so that'll happen. Okay, and this is in parentheses 2 to the power of 3 plus 4, and then it has over 2 to the power of 2. Okay, so how do you know what to do with this? Well, you're going to be using your order of operations, your PEMDAS. Okay, please excuse my dear Aunt Sally. And the way this works is you have parentheses are first, then exponents, and then you actually have a choice of multiplication or division, but you're going to be going left to right. Now in this case we have just an expression, but just to remind you. And then after all the multiplication and division is done in order of operations, you would do addition or subtraction. And whichever comes first, going from left to right. Okay, so let's take a look. Let me switch colors. So what's the first thing we're going to do? Well, we have parentheses is our first thing to do. So we've got some work inside the parentheses. So let's go ahead and do that. And I'll do that over here. So I have 2, let's look at our parentheses, only 2 to the power of 3 plus 4. So 2 to the power of 3, I'm going to let you take a guess on that, okay? So think about what that is and write that down, okay? You can just pause the recording, write down what you think that is, and then come back and turn it on. 2 to the power of 3. 2 to the power of 3 means 2 times 2 times 2. That's what the power of 3 means. It means take this base number. This is an exponent. It means we're going to multiply it 3 times. Then plus 4. So how do we know what to do here first? Maybe we should add 2 plus 4. Well, let's go back to our order of operations. We do multiplication or division before any addition or subtraction. So underline this. This is a good way to do it. It's just to underline the part you're going to work with. So this is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. 8 plus 4. So now we can add that, and that equals 12. So now we're going to come back and we're going to rewrite the expression. This is what I would do. I would write it over, just filling in the parts that you have now completed. So this is 3 squared, and then parentheses we have 12. Then we have 2 squared, like this, at the bottom. By squared, I mean 3 to the power of 2. 2 to the power of 2. Okay? All right, so now what do we do? So again, we can take a look at this. It's a multiplication. Let's go ahead and multiply, because multiplication typically comes first. And actually, we have an exponent. So let's take care of the rest of the exponents. Okay, we have 3 to the power of 2 and 2 to the power of 2. So let's go ahead and do that. So we have 3 to the power of 2 equals 3 times 3, and that equals 9. We have 2 to the power of 2, which is equal to 2 times 2, and that equals 4. So let's go and fill those in. So now we have 9. I guess I'll move it down just a little bit here. I'll do a different color. So now we have 9 times, and I'm going to take this out of the parentheses and just go ahead, I'll just put a times sign, times 12. Because that's what that means. Up against the parentheses, no multiplication sign or anything, that means times. 9 times 12 over 4. Okay? 9 times 12 over 4. So because this is in a form of a fraction, now you can kind of look at, even though we have these PEMDAS rules here that say multiplication before division, because we're in a fraction, we're kind of, and we've got this thing sort of factored out, because it's in a fraction form, you can also use your rules for fractions as well. So now we just have a fraction, and we can actually, if we can simplify early, we can save ourselves some time, okay? So we could say 9 times 12, we could say equals 108. Okay, we go through this whole thing and then divide and then over 4. We could certainly do that. Then we could do our division. So I'll come over here where I have some room. 108 divide by 4. I could go ahead and do that because remember, this is what this literally means. It means I have 4 pieces to make a whole. If that was a pizza, 4 pieces to make a whole. I have 108 slices. How many groups of 4? How many whole pizzas can I make? So you can just go through and work this through. Okay, I'll show all the steps there. So that's 2 and 8. So I can make 27 whole pizzas. Okay, but there's a shortcut too. So math very often provides some cool shortcuts. So let's look at something else here. What I could do, and I think I'll just go make some space on this. Okay. And you can find, if you have scratch paper or if you have some space here. Whoops. I'll just put some space up here. Shouldn't have erased all that right there, but maybe I'll put some of that back. Okay, hold on here. Let's put the original, let's put this original thing back. Get rid of that real fast. That's okay. Okay, so now let's go ahead and come up here. We have 9 times 12 over 4, okay, equals 1. Oh. Okay. So what we can do is we can actually do some division here or some simplifying first. So here you've got a 4 on the bottom, right? 4 is your denominator, and then you've got this 12. So I can actually simplify early on. And why I can do that is because it is both of these are part of the numerator, so they're both grouping together. So I could say, you know what, I could divide this by 4, and I could divide this by 4. So I would come up with 12 divided by 4 is 3. So I'd come up with 9 times 12 divided by 4 is 3. 9 times 3 over 4 divided by 4 is 1. So you're simplifying early on, and then that really makes it easy. Now all you have is 9 times 3 is 27. Okay. So also just want to show you, if you're really flexible with your numbers, flexible with your math thinking, we can also think of this as 9 times, or 9 copies, because multiplication means copies. I could write 9 copies, that's what this means, of 12 fourths. Well, 12 fourths is just 3, so then I'm really just saying 9 copies, or 9 times 3. Again, 27. So lots of ways to come up with that answer, okay? All right, let's take a look at the next one. Okay, take a look at this one. The grid shown below is in the shape of a rectangle, okay? What's the area in square units? And of course, area, when we're talking about area, we mean covering. It's like covering a floor is a good way to think of it. Covering a floor with squares. That's what we mean by area. Perimeter would be going around the outside of that floor. Let's say this is a floor, going around the outside of it and painting a line all around the outside. How long would that line be? Okay, area, covering it up. So we have, what's the shaded part? Well, the first thing you would notice is this shape is a triangle. So you got all kinds of ways to do that. When you started in 3rd grade on this, you started by just numbering the squares. You could go 1, 2, 3, 4, 5, 6, 7. You could number all these things. 14, 15, 16, 17, 18, 19. We'll say that's a whole one, 20. And then you could start to see, well, how many squares could I put together? You know, you could try something like this. You might say, well, I could put that together, and that's going to make 21, and then let's see, maybe these two together would make 22. So you might be able to go through and get pretty close. That one and that one, maybe that's 23. Maybe I've got 24, 25. It's, you know, kind of hard to look. Then you could look down here and say, well, you know, it's probably about 24 as I number those. But it's kind of a not a very efficient way to do it, not a quick way. You want the math to work for you. So what's a faster way? What's a faster way? Just looking at. So I want you to think about that. And you tell me, okay? Think about that. What would a faster thing be? Well, what do you know about this whole thing? This whole thing is a rectangle. And how much of it is shaded? So 1/2 is shaded. So let's think about that. If 1/2 is shaded, how could you use that information? So could you figure out how many squares are there in total? And the answer is yeah. You could look. There's 1, 2, 3, 4, 5, 6 in a row, and there are 1, 2, 3, 4, 5, 6, 7, 8. So you could say there are 6 in a row. So 6 rows. Oh, sorry. 6 in a row. So we'll say there are 6 columns. Okay, 6 columns. Times how many rows? 1, 2, 3, 4, 5, 6, 7, 8. Times 8 rows. Again, that's going back to 3rd grade. That's an array. 6 times 8. So 6 times 8. 6 times 8 is 48. There are 48 square units in the whole thing. Now notice they're going to have that as an answer choice, because usually, so you have to be smart with your test taking strategies. A lot of times students will, if they find an answer and they see it that it's or they calculate an answer like 48, then they look down and say, oh, it's there, so it's got to be right. So you know, you just have to be smart about that. So the whole thing is 48. So then half of that, what's 1/2 of 48? Okay, and you could do long division, or you could just kind of guess that 1/2 of 48 is 24. Okay, there's one way to get it. Just simply take a look at the total number, then take half. What's really interesting is that is where the formula for a triangle comes into play. So you have the area of a rectangle. Okay, so area of a rectangle is area equals, we just did it, the length. Okay, in this case the length would be 8, the length times the width. So another way to think of it, area equals 8 times 6. Of course, if I switch those around, it doesn't matter. Area equals 48 square units. Area of a triangle, so a triangle is half of a rectangle, and there's where we get the area of a triangle is 1/2, and we'll go ahead and put in parentheses the length times the width. But a triangle doesn't really have a length and a width, and so we change the name and we say the triangle is 1/2 of the base. So there's our base, okay, which is 6, and then our height, which is 8. Okay. Oops. So that's where that formula comes from. The formula is just a shortcut that helps us. So 1/2 base times height. Area equals 1/2. 6, the base is 6 times 8. I'm just using the dot there. Okay. All right. Good job. Good job. Let's look at another one. Okay. Let's look at the next one. This one. Oh, by the way, the previous problem about a triangle and the formula for a triangle, that's 6th grade. That's the first year that you learn how to figure out that formula. So that's really cool in 6th. And this is also cool because this is about a ratio. So it says Deb Neal has 6 teaspoons of salt. Okay. The ratio, so now we know we're talking about ratios, and of teaspoons to tablespoons is 3 to 1. How many tablespoons of salt does Danielle have? So we're looking for tablespoons of salt. So when you have a ratio, and there's always a number of ways to solve this, you could actually just draw a picture of this, and then you could also use your ratio scale. So we could actually just draw a picture and say he's got 6 teaspoons of salt. So we could just draw 6 of those. 1, 2, 3, 4, 5, 6. And those are 6 teaspoons. Always remember that math, any problem we have in math is something that can be done in the real world. In other words, we can actually take the 6 teaspoons of salt and we could just pretend like there they are, okay? Next thing that says the ratio of teaspoons to tablespoons is 3 to 1. And they give it in this order, 3 teaspoons to tablespoons. This means 3 teaspoons, we're going to take the same order, 3 teaspoons to 1 tablespoon. Whoops, ran out of room there. 3 teaspoons to 1 tablespoon. So I can come over here and say, okay, well, let's see. That means for every, using ratio language, like you learned at the very beginning of this unit, that means, basically just means this. If you know some of these big ideas, they're just very powerful. For every 3 teaspoons, there are, or in this case it's singular, there is 1 tablespoon. Whoops. So we can do this whole thing with a picture. For every 3 teaspoons, 1 tablespoon. So there you go, there's 3. So that must be 1 tablespoon. For every 3, that is another 1, and I'm just going to put TBS, tablespoon. Maybe I put a P there, forget. Okay, so our answer is there's 2 tablespoons. So we can just do this just by your understanding of a ratio and drawing a picture. So remember that. There's, don't just sort of automatically say, oh, I'm going to put these numbers and do some kind of a memorized algorithm. Make this thing make sense, okay? So let's look at another way to do this. Let me take this out. Big idea there we used just was ratio language, and being able to draw a picture. Those, if you can just draw a picture of them, most things can be done that way, okay? All right, let's take a look at this. So we know we're dealing with the ratio. One of the most powerful tools, the big idea with ratios, comes from our understanding of equivalent fractions. So when we're talking about ratios, all we're talking about here is an equivalent ratio, equivalent ratios basically. So that's all we're going to set up is an equivalent ratio. So, and if you understand, this is just a tool, and just learn how to use the tool. So we have 6 teaspoons of salt. So you can just write that down. Okay, 6 TSP salt. Okay, then I'm going to come over and see, what do I see next in my problem? It's a ratio, so I'm going to use my knowledge of equivalent ratios. Teaspoons to tablespoons, 3 to 1. So I'm going to write this as a fraction. 3 teaspoons to 1 tablespoon. Okay, so whenever you have equivalent ratios, you're always gonna set them up just like you would equivalent fractions, and you always have one unknown. So this just becomes a tool. So you can do this for any ratio problem. And if you prefer, you can still draw it out. There's nothing wrong with that. But if you know how to do this, set up 2 equivalent ratios, then what they call this is a proportion. And all a proportion is let's say you have to mix in, oil, like maybe if you have a 2-stroke engine, like say your 4-wheeler or something like that, and you have to mix 50 to 1. Okay, 50 to 1, 50 parts of gas to 1 part of oil. Well, when you're mixing that, you want the proportion, you want the amounts of oil and gas to be the same, whether it's for 1 gallon or 5 gallons. You want to have 50 parts of oil, 50 parts of gas to 1 part of oil. Or if you're baking, okay, if you're baking and you're making pancakes, and you want that proportion is there's 2 cups of milk for every, probably maybe 1 cup of milk for every 2 cups of flour. And so if you follow that proportion, you can make 1 batch or 2 batches or 10 batches, as long as in every batch of pancakes you have that 1 cup of milk. 1 cup of milk, there it is, to 2 cups of flour. Okay, so here we go. So now this is really easy. You can look straight across here and say, well, what's the relationship between this? I can go either way. This is like a ratio table is all it is. It's just a ratio table. Look across here. You're just saying, here's teaspoons and here's tablespoons. I got 6 and 3. What's the ratio? Well, 3 times, you can go backwards, or you can go times 2 to get this way. Times 2 going this way, or you can go divide by 2, and that should, even though it's hard for me to draw it on there, it should be a reminder of what you studied with your ratios. Let's try it one more time. Make it look a little better here. So we'll do 6, and we've got 3, so it's divide by 2 to get over to this side of 3. So if I do that, if I divide by 2, then that means I have to have something divided by 2. Something divided by 2 equals 1. So then you have to think through, well, what divided by 2 equals 1? The answer is, well, oops, hold on. Oops, so we're back. So 2 divided by 2, so 2 divided by 2 equals 1. Or you could have thought of it going this way, which is even easier. 3 times what is 2? 3 times 2. So you could have said this times 2, and then you would have said this term times 2. Okay? So either way, we've got that. All right, ratios, really cool stuff. Let's go look at another. Okay, and actually, I'm just going to wind up this video. So we only did a few of the problems, and I'll just do another video with the others. But remember, you can go through these as fast as you want, or you can go back and listen. You don't need to watch the whole thing. If you're really comfortable with ratios and you already know how to set up a proportion, well, then you can just go through the video and find that spot. So I'm going to keep going. I'm going to upload this one, and I'll do another one. And so hope to see you again in a little bit here.